Okay, some of these didn't come out. Now these are just very mechanical. It's like,
Okay.
this is an insult if we don't get them.
Insult to your loins?
It's an insult to my loins.
Oh, Mr. Black, I found my homework at
Yeah, okay, so which ones didn't come out?
5.
7, 9.
Okay, number 5, 7, and 9.
5.
Okay, f equals square root of x plus, it says find the second partials. So first you have to find the partial with respect to x, then you find the partial with respect to y. How?
Yes.
Partial with respect to x.
1 over 2 root x plus y squared. 1.
Okay, and then Wang, the partial with respect to y.
Y times x plus, parentheses x plus y squared to the negative 1 half.
Like that.
Oh, yeah.
All right, and then now we have to find the mixed partial. So the first one is the partial of f with respect to x. So you just take this one and differentiate it with respect to x. So I'm assuming you're rewriting that as 1/2 x plus y squared to the negative half.
Yeah.
So that's going to be negative 1/4 x plus y squared to the negative 3/2 times 1. Oh, you got that?
Yeah.
And then the partial of f, the second partial, with respect to y. So this one is the same thing as y times x plus y squared to the negative half. That means we got to use product rule on that.
Yeah.
Derivative of the first, leave the second one alone, plus the first one times negative half x plus y squared to the negative 3/2 times the derivative of box, which is 2y. Did we get that?
Yeah.
The 2's cancel out. Factor out an x plus y squared to the negative 3/2. And what's going to be left?
Oh, you can do that.
Yeah, it's called factoring x plus y squared minus y squared. Oh, the y squareds cancel out. And so you just have x times x plus y squared to the negative 3/2. So the problem was we couldn't simplify that.
That's.
So it's,
Wait. Negative. Oh, wait. No.
It's just not coming in.
because look, when you multiply things together, you add the exponents. Negative 3/2 plus 1 is negative half.
Yeah, this is fun.
Wait, what does the x come out? Oh, wait. Never mind.
And then now the mixed partial. The second derivative of f, and it doesn't matter which one you do first, right? Equals. So what do you want to do? You want to look at this one and take it with respect to y, or you want to look at that one and take it with respect to x? Okay, let's look at the first one then. Here's the first one. Take the derivative with respect to y. So you get negative 1/4 x plus y squared to the negative 3/2 times the derivative of box, which is 2y. And then how do you simplify that? Negative y over 2 x plus y squared to the negative 3/2. This is just mechanical. My goodness.
Wait, sorry. Can.
You did which one first? No. Well, you took which one?
I did the partial with respect to x first and then y. So we already did that one. So just take the derivative of this one with respect to y. But it shouldn't matter, right?
Yeah.
Because they're equal.
It's for the second derivative of y, why do you get the x plus y squared, or cos x plus y squared to negative 1/2?
You gotta use the product
Oh,
rule.
product rule.
Derivative of the first, leave
Oh.
the sec. This is MVC! We don't even know product rule.
I forgot.
Are you serious? You forgot the
No,
product rule?
I didn't forget the product rule, I just forgot to do it.
Okay, are those the answers that are printed on the thing? I believe they are.
Okay.
Come on, people, we're MVC. Anyway, if your answers don't come out, don't you go like, oh, I'm gonna look back and figure out my mistake.
Yeah, and that's why I get so confused.
Shoot. Okay, what's the next number? I'm gonna erase now.
Number 7.
Number
Yeah, I
seven.
think 7.
Number 7.
Wait, every time in the book it says log, it means ln.
Yes.
Yeah, that made me confused.
Yeah, that's, I don't know why
That's just-
this author does that, but he does. Anyway, I used this book at UH 30 something years ago. So natural log of x over x plus y. Okay, so first we find the partial with respect to x. So that would be 1 over box times the derivative of box. But then since it's a quotient, you gotta use the quotient rule. So you got low d high minus high d low 1 all over denominator squared we go. So that's gonna be, the x's cancel out, y over, and then when you multiply this times this, the x plus y cancels out, so you're gonna get x times x plus y. You got that? Okay, how come we're, I guess it's the second partial then, yeah? Then if you take it with respect to y, you're gonna get 1 over box times the derivative of box, low, d high, which is 0. Why are we using quotient rule when that's a constant? That's okay. Minus high, d low, 1, all over denominator squared we go. So you get negative x over x times x plus y. Okay, you got that? I'm not sure why we did the product rule, but we did.
Oh, wait, isn't that just negative 1 over x?
Oh yeah, the x's cancel out. Negative 1 over x plus y. How come I didn't see that? Getting old, that's what happens. Okay, now we do the second partial. The partial of f with respect to x is, so where's the answer here? Now you gotta take the derivative of that with respect to x. So do you want to rewrite that as
Yes.
y, x to the negative 1, x plus y to the negative 1?
Oh. I just multiplied by.
What?
I
You do
multiplied
y
the
over,
bottom
yeah.
out.
Y
X squared
over
plus xy.
Yeah,
Yeah.
that one looks complicated.
Really? So x squared plus xy to the negative 1. But see, if you're taking the derivative with respect to x, this is just a constant, so you throw it on the side. And so you get negative box to the negative 2 times the derivative of box, which is 2x plus y. You can't really simplify that too much, yeah? Negative y, 2x plus y, over x squared plus xy squared. How does the book write their answer?
1 over x plus y squared minus 1 over x squared.
Say that again?
1
1,
over x plus y quantity squared minus 1 over.
well, in the denominator or minus like that?
Yeah, minus 1 over x squared.
Oh, they split it up into separate terms.
That's
Why? Why would you do that? Oh, well, let's see what they did. So if you make a least common denominator, you get x squared minus x squared minus 2xy minus y squared. These cancel out. Factor out a negative y, and you get 2x plus y all over x squared times x plus y quantity squared. That's the same thing, right? Yeah, so it's the same. Why would they write it like that? Maybe they took the derivative in a different way. I'm not sure what they did. I would say just leave it like that. It's better. See, so your answer was correct then, huh? Did you even bother to check to see if it was the same?
Yeah, no, I didn't like
Boo. The partial of f, second partial with respect to y now. So here's y, this is like negative x plus y to the negative 1. So the derivative is going to be 1 x plus y to the negative 2 times the derivative of box, which is 1. Okay, that was easy. And then the mixed partial. The second partial with first you want to do it with let's do it with respect to y first, and then with respect to x. You know why? Because this is a much nicer expression. This one, yeah? So if you take the derivative of this one with respect to x, you get positive 1 x plus y to the negative 2 times the derivative of box, which is 1. And there you go. Very mechanical. Anyway, you know, later on it's going to be better. You want it like this. You don't want to make separate terms, because later on we're going to have to know, just like in BC, when it's positive and when it's negative. So you want it in factored form. Can I erase?
Wait. Sorry.
This is just algebra. Can I erase this side of the board, please?
Yeah, that's the same. No, not all of it yet. Yeah, left side you can.
Okay, what's the next problem? Let me just write down the next problem. Number 9. Okay, so now you got a function of 3 variables. X plus y, y plus, this looks interesting.
You have to, can you multiply like one of them out first, or 2 of them out first, and then do the product rule?
If you want to, you can do it. I mean, as long as it's mathematically correct, you're gonna get the same thing. Doesn't matter.
Or is there like a way to do like 3 like product rule?
Yes, we learned that last year.
Yeah.
The derivative of the first, leave the other 2 alone.
Oh,
Then you take the derivative of the second one, leave the other 2 alone. Then take the derivative of the third one, leave the other 2 alone. Does that sound familiar?
Yes.
Okay, I'm erasing. Too bad. So first we gotta find the partial with respect to x, then the partial with respect to y, and then the partial with respect to z. So I'll do the first one. The partial with respect to x, you just have to look at these 2 because this is a constant, right? Right, because x is the variable, y and z are constant. So you throw the constant on the side like an unwanted pet.
Yeah.
And then you just use the product rule. So derivative of the first, which is 1,
Oh, that's so much easier.
1, leave the second one alone, plus leave the first one alone, derivative of the second, which is 1. Why am I writing the 1? And so you just get y plus z times 2x plus y plus z. I think there's pretty much gonna be a pattern, right? Do you see the pattern? Because each factor is like the same thing except, so here, following the pattern, what do you think this one's gonna be?
Z plus
X plus z times
2y.
2y plus x plus z. And then this one's gonna be x plus y times 2z plus x plus y. Correct?
Yeah.
Okay, those are the easy ones. Now we're gonna do the second partials. So, the second partial of f with respect to x, second partial of f with respect to y, second partial of f with respect to z. Uh-oh. What about the other ones though?
Can. Oh yeah.
So you,
They just all be same pattern.
no, but
Oh, you mean
then you gotta do second
Yeah.
partial of f,
dx.
then there's gonna,
There's 3 more.
then you do it with respect to x first, then with respect to y.
Yeah.
And then you do the second partial with respect to x, then with respect to z, and then the second partial of f with respect to y, then z. I guess.
Yeah.
Okay, let's roll up our sleeves and start going. So here's the partial of f. So we got to take the derivative of this with respect to x, but easy. That's a constant. Throw it on the side like an unwanted pet.
Yeah.
And then you multiply it by the derivative of that, which is 2. Come on.
That's not what the
It's just the same.
Why, what does the book have?
I'm pretty sure it had no truths. That's why I said.
But the derivative of 2x is 2, though.
Yeah, I know.
There is a 2.
That's why I'm.
There is a 2 in the answer.
It's just 2 times what?
Wait, what?
What do you mean there's no 2? There is a 2. Are you looking at it wrong? That's 16.
Oh my god. I was
Oh
looking
my-
at the wrong answer.
Is that why all your answers are wrong?
Please,
Yeah.
please.
Yeah, there you go.
That's why you said all your answers are
Good night,
wrong.
yeah.
And then if you take the derivative of this with respect to y, you throw the constant on the side like an unwanted pet, then 2. And then same thing, throw the constant on the side like an unwanted pet, 2. Do we even have to continue the charade?
No.
We don't. Okay.
Wait.
Well, maybe these would be more difficult. So the second partial of f, first with respect to x, then to y. So this one we already did it with respect to x already. So now do it with respect to y. Oh, we got to use product rule. I'm going to erase this because we're going to need. So this one's going to be some work. So we got to take the derivative of this one with respect to y. So derivative of the first 1, leave the second one alone. Plus leave the first one alone, derivative of the second, which is 1. So that comes out to 2x plus 2y plus 2z. Oh, I wonder if all of them, do they all come out to that? They should, yeah? You
Should.
would think.
Yeah.
Yeah, they do.
Yeah, okay.
Just in different order.
Yeah, but there's no order really yet, so. Yeah, we don't need to do the other two.
We're done.
No, you said 2.
Yeah, that's fine, so.
So like all of your answers didn't match.
Oh, shoots.
Or you did the.
He was like every single one I got, they were all wrong.
Well, what answers were you looking at? Or you just looking at the wrong
He was
number?
just 16.4.
I think like somehow, like the first 2 were right, and then
The
somehow
first 2
I-
are right.
Somehow I like switched the sheets somehow, and then like the answer was like close enough for me to be confused, but then like.
All right, so for those of you watching the video, the test is on Monday now.